here. We love doing full stack here at Planning Center. I should introduce myself. My name is Dana. I work here at Planning Center with Chan, who's going to be our first speaker. I have no idea what he's talking about. Pokédex, fake Pokemon. Yeah, it's going to be real fun, I'm sure. Looks very interesting. It's very scientific, I can tell. I think it's not scientific. I can't tell anything. I don't know. My job at Planning Center is to talk to people all day, so I don't talk to computers really, so I don't know what I'm talking about. I'm literally just making things up. It's fine. So at Full Stack, one of the things that we genuinely care about is community. So we are so excited that you are here tonight. We hope that you learn something, make some connections with people here. One of the things that we're going to talk about, not right now, is if there are any job openings at your company or if anybody here is looking for a job. We're going to talk about that in a little while. But right now, I'm just going to introduce our first speaker, Michael Chan, the most friendly-voiced man I've ever met in my life. That's a lie. Don't believe me. But he is wonderful. And anyway, I don't have any other words. Chan, please come to the stage.
Thank you.
That's really hard to do.
Having the stage is always so weird when there's like 10 people here. I tried to move it down, but the HDMI cable was not long enough. It resisted me. Story of my life. So, today I am going to give you a very short, condensed introduction to React Suspense. React Suspense is super cool. I'm going to try to cover all of the features that are, like, I guess, public in the experimental phase of this thing in 20-ish minutes. So we'll see how far we get. But yeah, so a couple things. There's like 4 things that I'm not really going to cover, which is if you want to use this, there's this new like experimental channel. You just npm npm install react at experimental, and you get one of these like weird hash versions. So that's the first thing that you need to know that I'm not going to be talking about. And then you don't use react dom.render anymore. You use this like create root thing if you want to use concurrent mode. I'm not going to talk about that. And error boundaries, if you're not using them, it's basically you just copy and paste this code into your application and you have an error boundary. So I've already done that here, so I'm not going to be showing you how to do that. And then finally, there's another piece of code that I have copy and pasted, which you will understand later. But this is used in all of the React Suspense or concurrent mode documentation. So I've just copied and pasted that so I don't have to do it while we're talking. So the other thing is I buy way too many domain names. So if you want links to anything regarding this, I'll put the GitHub thing on there too. You can go to reactsuspense.com. Let's dive in. So the first thing the first place that I like to start with Suspense is back in my application. For a year now, we've been able to use Suspense with this feature called react.lazy, which allows us to dynamically load code kind of after we've like rendered our initial app to the client. It's called code splitting. And so that's actually, so we've been able to use React Suspense with that, for that use case for like a little over a year now. So to show you your first Suspense component, we're just going to change this from a static import to a dynamic import. And those look like this. So we say import, and we give it the path. We call import as a function. So Pokemon detail. My typing might be a little bit off today because my N key is broken, and I just got a flu shot, so my left arm is a little numb. Now, so import is just a promise, right? And so promises can have 3 statuses. They can be pending, resolved, or rejected. Now, React itself does not know how to like work with promises like directly. So anytime we have a promise that we want to like know the status of and be able to connect it to React, we have to wrap it in something else that knows how to like tell React what's going on. So we're going to wrap it in this handy little function that React gives us called React Lazy. And then we'll just assign that to the name that we had before, which is Pokemon detail. No, I'll just type it then. And now everything should break violently. So in order to like do all of this like suspensey stuff, Suspense is a way to kind of like while things are loading, easily show fallback stuff. Now, this screen is so small. Okay, let's see if I can find what I'm looking for. Okay, so one of my favorite things is the React errors are always super good, and they give us this really things like, hey, an error occurred. Like, if you want to know what happened, like try to install one of these error boundaries. They give you a link. Talked about that. I already copy and pasted that into my code, and it's right here. So we'll just use one of those. Import error boundary from forum. Error boundary, cool. And then what we do is we just wrap the broken part of our code with that. Okay, we hit save. I'm gonna have to refresh on this side. Now, something super cool happens here. When we have an error boundary, first of all, it captures that error, and the way I have mine implemented, it logs that out for me to know what the error was. Second of all, anytime we put an error boundary in here, it actually protects the rest of our application from blowing up. So a second ago it was blowing up. Now this still renders fine, and anything else on the page would render fine, even though this got borked, which is sweet. So our error boundary component is catching that error. It's logging out the source of the problem to the console, which is telling us, hey, you need a suspense component. Like this thing is suspending. It's in a pending state, but you're not doing anything with that yet. So we just add one of those. React.suspense fallback. We'll just give it anything here. Let's say like loading Pokemon. So again, this is going to be in our pending state that we're going to see this message. Format that. Cool. So all we've done at this point is now we're lazy loading this component. So this component, this is like our main bundle in our application, and then once that loads, it then dynamically fetches this and kind of loads that component. Now, one thing that's really cool, I have the Chrome, the React dev tools for Chrome installed here, and I can actually, let's make this a little bit bigger. Because I have the suspense component, I can actually click this little thing and then see the loading state. So with very little code, I now have like the component that I want to render that I'm like loading asynchronously, a fallback state, and then catching any errors that happen. And then in here, if I wanted to style this and like don't want to have to like change the network speed to like 0, I can just like toggle this on and off. Really handy little tool there. So that's your first suspense component. Super easy. You got your thing. It renders when it's resolved. In the case that it's waiting, it shows the fallback, and then if there's ever an error, it's going to show this error state. Now, like I said, all of these are just promises. We don't really have a lot of time to for me to show you all these things, but you can go in here and you can change this to promise.reject, and it'll reject it right away, and you'll see the error boundary enacted. Or you can give it a promise that doesn't resolve, and you see this suspense just kind of hang there indefinitely. So you can play with that, just promises all the way down. So how does this all connect to data fetching? If we want to use this not for components, but we want to use this for data, how do we do that? Well, I copy and pasted a little bit of code that's in all of the concurrent docs, and I have a little API function. So we're going to fetch a Pokemon. We'll just give it an ID, and it'll just kind of give us all the data for a Pokemon using the Poke API, which is dope. Now, again, anytime we have so fetch returns a promise, and anytime we have a promise that we want to communicate the status of to React, we have to wrap it in some type of wrapper that actually connects the statuses to React land language. And then this I just copy and pasted from the docs. I'm going to call this Suspensify. You can read more about that if you want, but basically it's just that connective tissue between our raw promise and React. So let's go in here and let's import some data. So const, we'll call this initial Pokemon. We're going to fetch Pokemon of 1, and we're going to suspensify that. We'll then import, fetch Pokemon, and suspensify from API. Okay, let's see how we did. Okay, cool. So now we have this, our initial Pokemon. Let's send it down to our Pokemon detail component. I'm bound to make mistakes, so call them out as you see them. Oops. Okay, now one thing about the way this API is situated is that these, in order to actually like recall, like so let's say your promise is pending and it suspends your component. In order to actually like recall that, we need to have a function that we can call. And so the one thing that this gives us is suspense will return an object with a read function, and that's what actually allows us to reread once that promise is resolved. So we are going to just interpolate that out. Pokemon read, we're going to call that function. And from the resulting object, we're going to call name on that. And there we get Bulbasaur. Pretty easy. Not a whole lot of lines of code to be able to use suspense for data fetching. So pretty easy so far. We have a Pokemon. We're passing that resource down to this component that we're lazily rendering. We're wrapping up all of our promises in a way that can communicate all of this to suspense, which is super dope. Now let's. I'm going to change something in our API just so we can see some of the other sweet benefits. So here I'm just kind of randomizing like how long each of these requests is going to take to simulate some level of latency, and this is so we kind of see some random wait times for this loading Pokemon fallback. Whoa, what'd I do? Cool. So let's see, what's the next thing I want to talk about? Okay, cool. So we have a Pokemon. We want to now like grab the next Pokemon. I mean, like even in a 20-minute talk, an app that just loads one Pokemon is not super interesting. So we're gonna add a button. Button type. Button. And this is gonna go to the next Pokemon. Have some kind of on-click handler there. And I think for now, let's just alert dot read ID +1. So we're just going to alert the ID of the next Pokemon. I think that's, oops, no breakpoint. Okay, so we hit next and we get 2. Cool. Now, if we want to keep our Pokemon around and like be able to switch on that, we can use state to actually like track which Pokemon we want to be on. So let's use that. So we'll use this use state hook. We'll give it our initial Pokemon to start. That'll be our default or our starting place. We'll take the resulting Pokemon that we get as Pokemon. So we'll pull that off as Pokemon. Now we got to change up our code a little bit. Pokemon, send that resource down, and then over here. What was that? Line 40. 40. Oh yeah, poke a. Cool. There we go. Okay, so now we're using React State to store that. So we can actually update this in state. So we'll change this to set Pokemon. We'll peel that function out this array. And then we can just call that same function again. Let's grab that. Our suspensified fetch Pokemon with the new ID. Add a couple parentheses onto that thing. Let's see what we get. Cool. So now we can kind of progress through. We see this whole like loading state dance. It's going to be randomized every time. And that's looking pretty good. But we have a little issue here. We now have 4 errors. So React is usually pretty good about errors. So let's see what that's about. Warning, app triggered a user blocking update that suspended. To fix this, split the update into multiple parts. So one thing that concurrent mode does, and so this will be new to you if you've, if suspense and concurrent mode are new to you. Concurrent mode allows you to, or allows React to make decisions about what the most high priority things are to like re-render the page. So the thing is that like I'm doing this fetching, but between the fetching and the re-rendering and the suspending and all that kind of stuff, this might actually block like user interactivity if I had like 5 other buttons and I wanted to like click those while I was doing this thing. So this is warning me saying like, hey, all of your things, all of your set states, and all of your suspensified business is all like kind of like high priority. You're in the fast lane right now. You can deprioritize these with use transition. So let's use transition. React.use transition. And then by convention, this first element on the array is start transition. Okay, you can name it whatever the heck you want, but by convention, that's how you'll see it in the docs. Now, start transition is pretty easy. Anytime we have like a set state or something like that, we're just going to wrap it. So we have our set state for Pokemon that does that like fetch request. We're just going to wrap that in start transition, and now that error should go away. Whoops. I clicked it too fast. Whoops. What was that? Did I set another breakpoint? Freaking. Oh, wait, maybe because I'm in the source panel on accident. Yeah, that was it. Okay, cool. Why does that happen? Oh, man. Or maybe I did actually break something. Oh, well. Anyway, it works enough. Yeah, but that didn't fit in the 20 minutes, Michael. Okay, so we're gonna go with it. Hopefully, here, maybe if I just close the Chrome DevTools, it'll work. There we go. There we go. It's working now. Hey, yeah. So hopefully your users don't have the Chrome DevTools open, because this would just break for them. This is the speed run, okay? Okay, so now, the thing is that there's this concept now of the, they call it like a receded state. You'll see this in the documentation, where you click this thing, and then you see this like loading Pokemon again. And that's because we're doing this fetch that's telling the component like, hey, we're doing some work, so like, can you show the fallback, please? But that's not really how we like interact with user interfaces. We like to keep the thing that we already have around. So use transition takes some customization options, and one of them is time. I can never spell this word right. Timeout MS, and we can set a threshold for how long we want the previous rendering to stick around before we jump to the next one. Which is pretty cool. So I just add that one configuration point, and now this is going to hold on to Bulbasaur until Ivysaur comes back. So I'll click it again. It's going to hold on to Ivysaur until Venusaur comes back, which is pretty neat. But you'll notice like this still isn't very great user interface because we're clicking the button and we don't there's no indication that like something's happening. So they thought of this as well. And the second element that use transition returns, by convention, we call it is pending, is a Boolean. And we can use that to kind of show certain, like an indication that things are happening while the work is happening to fetch that data. So let's see, so pending, we'll just put like 3 dots right there. Okay, so if I hit next, now I get a little 3 dots, and then as soon as that thing resolves, the dots go away. The dots. So obviously you would want to make this like prettier because that's not like super beautiful, but is pending is how you would like provide some additional cues to your user that something is, that work is happening. You can present that to them right away, and then they immediately go away as soon as that everything is resolved, which is super sweet. Okay, so that's it. That's pretty much it, except let's add some more data. I know I'm like really close on time here, so we're just gonna do a little bit more. So Pokemon collection. We're gonna fetch the collection of Pokemon, so we'll call it with no arguments, that'll just get all of them. And then we're gonna make a component, function, Pokemon collection. It's gonna just read that directly. Pokemon collection dot read. It's getting hairy. Dot count. Okay, so count is just like some meta property on the returned. Oh, yeah, there we go. Thanks, everybody. Okay, so we have that. Now we can render it. Let's just copy this whole little. Let's copy this whole little thing since we already got it, and this will be loading all Pokemon. We'll delete this off of there. Pokemon collection. Cool. Okay, so now we see, you got to see there just for a split second that these kind of load independently, right? And so the first one to resolve is going to be the first one to render, and then the other one kind of, when it resolves, it renders. It'd be nice if we could coordinate how these things render. And React does give us a pretty nifty tool for this called Suspense List. And this is for any time you have a bunch of suspense components that you want to coordinate their rendering together. So I'm going to save this, and it's going to blow up, or it should blow up. I think as soon as we use one of the props, it'll blow up. So the prop that you have to control these is called reveal order, and there are 3 options. There is together, forwards, and backwards. Now, one thing that you need to keep in mind is that the direct children of this suspense list need to be suspense components. So you can just swap these error boundaries in place. You'll get the same effective behavior, but now you can have the suspense on the outside for the suspense list. So we're using together, and you'll notice that as I refresh this, these will always render together. So this is kind of like promise.all. All of them have to resolve before any of them can render, which is kind of nice. You can change this to be forwards, which will always resolve the first one first. So sometimes they'll render together, but if I can refresh it enough times so that the first one comes in before, screw off. Not you. Man, I cannot get anything done with those DevTools open. What did I do? I have a break. I accidentally clicked a breakpoint somewhere. I'm sure of it. Okay, do it. Oh, there we go. Oh, yeah, we found one. We got one. Whew. Okay, so we got one. So reveal order. That's pretty sweet. So now. No. Okay, so one last one, and then we'll learn about Rust. There's one other property that you'll want to know about, and this is actually pretty neat. In conjunction with reveal order, this can give you some really nice user experiences. So tail is like, what does it do with the rest of the list? So as it's rendering the first one, let's say you have 10 things in this list. Like, what does it do with all the rest of the 10? You don't want to see like 10 individual loading states, right? So tail has 2 options: hidden and collapsed. Hidden is just like, don't show me anything. Okay, I don't know if you saw that. I'll render it again, and of course they're going to come in together. But basically, it's not going to show you anything. Okay, so collapsed is actually is my favorite. and this is what we'll end with. What it does is it doesn't show the second one until the first one's resolved. So you render. I know. Is it once in a lifetime opportunity right there? I need to learn how to write more diverse set timeouts. Is what I'm learning. Um, so anyway, it's a pretty cool little feature which I will never be able to get to enact again. So anyway, those are like pretty much all of the things that are available to know about suspense at this point. So now you're an expert, you know everything, and good luck.
I only call him Michael when everybody's listening. I never call him in person. I do not like standing there. Okay, we're gonna take a 15-minute break. So at 10 after, come back. There are restrooms right around here. There's a little white sign there pointing you to them. There's beer and snacks in the fridge if you want them. Please mingle, talk to each other, build community in this tiny little space we have, and we'll see you at 10 after. Hello, my little friends. If you are not in this room where you can see my funny face and hear my voice, please make your way over here. Thank you so much. Again, thank you guys so much for coming to Full Stack. One of the things that we really, really care about here is furthering, I don't know, the things that you're doing in your career. And one of the things that I genuinely appreciate about the developers at Planning Center is maybe two things. One, their devotion to learning. And I feel like when you are passionate about the things that you do, like you are always trying to figure out how to do those things better and learn and grow, because it's just exciting to learn and to polish your tools. And one of the ways that our devs do this regularly is feedback to one another. And one of the things that Michael said about, like, if I do something wrong, call me out on it. I hear that all the time around Planning Center, and I love that. So I think that's my favorite thing about listening to developers all day. I am not a developer. I am nowhere near smart enough to be a developer. I forget my own name sometimes. I can't imagine trying to remember all of these lists. What you called it, a list? Yeah, those things. It's not for me, my guy. It's just not. But I love that about our developers, that they are always genuinely trying to like teach each other and grow and all that kind of thing. And that's one of the reasons why we're doing Full Stack. Because, you know, one of the things about you having a day job is that you don't always have time to pursue things that you're interested in. And you don't always have time to pursue things that you would like to learn and that you would like to, I don't know, implement in your life. And so one of the cool things about Full Stack Talks is that maybe you can't use this information in your work life, but maybe you're interested in something, you want to challenge yourself, you want to push yourself to the next level. Doing a Full Stack Talk is a really great way to do that. So if you are interested in doing a Full Stack Talk, as you learned from Michael Chan, you do not have to have any qualifications. You can just get up here and take the microphone. But if you are interested in doing a talk, please let us know at, oh God, I always butcher this, talks@fullstacktalks.com. Let's just pretend that that's what it is. Cool. All right. But we really, really want you to have a place to talk about things that you're interested in. So without further ado, I'm going to introduce Tony, who's going to talk to us about, oh, wait, I'm sorry, I lied. I'm so sorry. I forgot to do my other thing about the hiring. Is there anybody here at their job who is hiring, or is there anybody here who is looking for a job and would like to share with this very open and welcoming community that you are looking for a job or that your company is hiring? Krista, what is your company hiring for? Anybody else? Ooh. C, Chad, Chaz, Charlie, Chimichanga. I don't know. What's your name? Chimichanga, what are you hiring for? So close. You guys, I'm real good with names too. Cool. All right, Chimichanga, what do you got for us?
I work at a company called Third and Grow. We are a digital agency, and we are looking for React developers. We're traditionally a Drupal shop. I've been training up my Drupal devs on React, and we're getting more work than I can handle on my own. So if you want to help me out, that would be great.
Thanks, Grant. All right, anybody else have hiring or looking for jobs they want to talk about? Okay. Talk to Grant if you want to know about Drupal. I don't know. Okay, when you said that, I'm like imagining like the big Legos like Duplo. What are those called? That's what I'm like yeah. That's exactly what I'm imagining. Guys, I could totally be a developer. This is fantastic. List, Drupals, yes, I am ready to go. All right, Tony, this time, I'm so sorry for the false one last time, but please come up and share with us about what you're a little rusty about. All right, there you go.
Is this thing on? Okay. I just have to say, I hired somebody from Full Stack about 4 years ago. We still have him. So it does work. Okay. Tonight, I'd like to talk to you a little bit about the Rust programming language. They always tell me that you got to open with a joke. But to be honest, I couldn't find anything funny about Rust. I mean, it's a funny word, Rust, but, you know, who in their right mind would name a systems programming language after what happens to iron after it gets too much air in the presence of water? And certainly no one in their right mind would come up with 80s movies references to throw in as pointless humor. So let's get started. I'm going to cover a few of these things here tonight. First of all, where can I get it? How often is it released? How is the library ecosystem? And then we're going to run our very first Rust program. And then we'll talk about what it all means. So, how do you get it? The good news is a lot of the Linux distros out there have added it as a package. So you can either yum it or apt it or APK it or whatever you want to do. But the preferred way for developers is actually to use a little tool called RustUp. So go to rustup.rs. Yes, they use RS for the domains for a lot of Rust things, which may or may not interest your security people at your companies. Luckily, it's Russia. No, you're right. Now I forgot. Anyway, that's why it'll interest your security people. Anyway, so if you go to rustup.rs, you will find one of those infamous curl this and then pipe it to bash kind of commands, because that's secure. I'm a security guy, by the way. Anyway, that will automatically install the most recent stable release of the Rust compiler, and you'll be off to the races. So, because Rust is brought to us by our good friends at Mozilla, it is built on the browser-style every 6 weeks release train. So everything starts in nightly and then progresses to beta and then to stable. I have to say, they take Semver more seriously than anybody I have ever seen before. In fact, they have a tool called Comet. Whenever they're about to put out a new version of the compiler, they actually recompile everything in the package system to make sure the compiler didn't break you. So that's pretty cool. I should check my own notes here. So the good news is they do take backwards compatibility very seriously. So if you wrote something, a couple of years ago with Rust 1.30, it will still compile today with Rust 1.39. And we'll talk about additions. So they put in, like I said, new features with every release, but they tend to bundle them up every couple of years, and they call these additions. The most recent one is the Rust 2018 edition. All of the new features come in automatically, unless they're breaking changes, in which case you have to actually tell it you want to use the new edition. That way, your code will always compile. Cargo is also part of that basic install. It is the Rust package manager. I more think of it as the Rust Swiss Army knife. It does just about everything. And it's called Cargo because packages are called crates. There we go. I didn't name these things. Don't pay me. So if you are at all familiar with Bundler from the Ruby world, you will be very comfortable with Cargo, because it was also written by Yehuda Katz, believe it or not. So this is your package manager. It is your build tool. It is your test runner. It is your benchmark runner. It does a whole bunch of good stuff. And it has its own book, so you can read all about it. Also, much like Bundler, you can write your own third-party extensions for it. Anything in your path that starts with cargo dash will suddenly become a subcommand of cargo. So in this example, I install a crate called cargo bloat with a very obvious cargo install cargo bloat, and then bloat now becomes a nice subcommand. In case you're curious, bloat lets you know why your binary just got so big, because you added 14 third-party libraries. All right, so like I said, packages in Rust are called crates. You go to crates.io to find them. Again, if you use Bundler, you know how this kind of works. There's a magic file called cargo.toml. You add all your dependencies. It figures out the dependencies of the dependencies, and life goes on. One interesting thing, if you are used to Bundler, especially in the old days, if two things need different versions of something deep down in the train, it actually just throws them both in. It doesn't have isolation problems like Ruby does, so you can actually have multiple versions of the same library all compiled in, and it works just fine. It also causes bloat, so there you go. In case you're wondering, TOML, if you haven't seen it before, is what I call a yact. So, with every language I've learned in the last, 10 years, they always have their own config file format, right? I learned YAML because of Ruby, etc. So they picked TOML. I don't know why. If you're having DOS INI flashbacks right now, it's because TOML looks a lot like those old files. If you have no idea what I just said, be happy. It stands, by the way, for Tom's Obvious Minimal Language. Also rolls off the tongue. All right, it's demo time. We're going to build our first Rust program. Yes. Wasn't that obvious? All right, let's hope the demo gods are with me. Okay, so cargo is also the way you make a new project. So we're going to say cargo new, my amazing first Rust program. And now I have a directory called that. So I'm going to cd in there. And now I have cargo.toml, which will look just like the one I showed you on the slide. And it has no dependencies, for example. And then in the source directory, you have exactly one file called main.rs. And it has the infamous hello world. So, any guesses on how we run this? That's right, cargo run, woo! And it's done. Wasn't that exciting? So, my point in showing you this is if you're used to, when people hear systems programming language, they think of C, right? And when you think of C, you think of makefiles and missing tab stops and all kinds of other ugliness. Rust avoids all of that. So don't avoid Rust because of that. Cargo takes care of all the fun things. Also, let me go back to slides. That was a single file program, so it wasn't all that exciting. However, you can get deep and complex with your directory tree, and there are, of course, conventions for where to put things. And then Cargo will still magically find modules, link them together. You can have multiple binaries, you can have example programs, you can have tests, you can have benchmarks, and it takes care of all of that. Okay. So now we've installed Rust, and we talked a little bit about building and running a program. So let's get back to what exactly is Rust. By the way, that's Ferris, their mascot, the little crab up there. Okay, so I'm going to ask the next super obvious question, right? Everybody ready? Why do we have garbage collectors? No, seriously, why do we have garbage collectors? Everybody, I've always wondered. And it probably is kind of an odd question for me to be asking at this point, but bear with me. So, I've been racking my brain trying to come up with a better answer to the question, what is Rust, than it's a systems programming language. It's super boring. Plus, I'd have to then spend 15 minutes defining what a systems programming language is, and I'd still come up with something that wouldn't adequately do what I'm talking about. So I'm going to try something different. Because to me, Rust is a game changer. This language does a lot that we've been waiting for, or at least I've been waiting for a long time. And the reason for that lies in the answer to the question, why do we have garbage collectors? So, garbage collectors are terrible for performance, and half the time they seem to cause almost as many problems as they solve. Plus, collectively, as in computer science, we've probably put a few thousand human years into garbage collector research and tuning, and that's just for the JVM. And the answer, of course, is memory is hard. Anyone who's written more than 10 lines of C knows that that is, in fact, the answer. The second answer is compilers are hard. Back when compilers were born, computers had so little memory that they couldn't remember more than that guy. Anyway, they couldn't keep track of anything, right? They barely could spit out the code you asked them to compile back in, say, the PDP-11 days. Anybody written a compiler in class? You recognize this book? No? All right. So we didn't expect a lot from our compilers. So the result of that was compilers left memory management up to humans. And this turned out to be an extraordinarily bad idea. So, can you spot the security vulnerability? Anybody know why that's a security vulnerability? So you create a buffer that's exactly 8 bytes long, and then you call something that will read into a buffer forever. And the Stack Overflow was invented. Here's John. John coined the phrase artificial intelligence. He worked at MIT. He created the programming language Lisp. He also invented garbage collectors. And nothing against John, but with the clarity of 2020 hindsight, he really took us on a detour and put us into a place where we felt like there were only two options: completely automatic memory management with garbage collectors and GC pauses and all that fun stuff, or nothing. All right. And this is why I think Rust is great, because it's something new. We've been stuck with these two choices for a long time, and it would be really nice to have a third choice. Oh. I say nothing about how I feel about these languages. So, what sets Rust apart from everything else? And the answer, of course, is memory management. That's why I've been going on about memory for 5 minutes or more. Rust obviously does not have a garbage collector, otherwise I wouldn't be talking about all this. But to accomplish memory management without a garbage collector and without leaving it up to you to remember everything, the compiler had to get more complicated. Now we have tons of memory. Now we can do all kinds of crazy stuff. And so the compiler keeps track of absolutely everything. First of all, everything's immutable by default. And then we're going to talk about the ownership model and the borrow checker, and my favorite, the root of all evil rule. Okay, so with Rust's ownership rules, you will create a vec. They call arrays or lists, they call them vectors. So we create a vec, and we assign it to v, and then we assign v to v2. Now, in most languages, you now have two things that point at the same chunk of memory. In Rust, it's very different. You've now moved v to v2, and v doesn't exist anymore, which means you can't accidentally give it to somebody when it doesn't point to v anymore because you released the memory, for instance. This is what we call a use after free bug. All right. It's a simple rule, but it means that the compiler can always keep track of who owns the memory and when to release it. Where am I? Okay. Oh, that was my example. Huh. Got to read my own slides. So this print statement would not work because it's trying to reference v, and v doesn't exist anymore. But the important thing here is you get that error at compile time, not at runtime, right? There's no joy better than running a Ruby program for 24 hours straight and having it fail on the next to last print statement because you mistyped a variable name, right? This won't let you do that. Okay. The other part of the memory management system is the borrow checker. And when you first learned Rust, no, but I can try it. I borrowed the video screen. Come on. It's going to be real hard to do this without slides. The answer is always hit spacebar one more time. Okay. So this is what I call the shared mutable state is the root of all evil rule. You can have as many references to something as you want as long as it's read-only. If the reference you have is read-write, you can only have one, period. Them's the rules. And the best part is the compiler's enforcing them. It's not like C++ where it pretends to enforce things and then lets you do them anyway. That's bad parenting. Okay. But what's important here is these rules seem kind of simple, but they really force you to think about your memory usage in a new and different way. But if you do it this way, you get no possibility of race conditions when you're writing multi-threaded code. You get no use after free bugs. You don't, I'll say mostly don't get memory leaks. There's always some way you can get yourself into a state where you can get a memory leak. and you're not going to have dangling pointers or other issues. The compiler just simply won't let you. So no random crashing. No, it crashes sometimes when the moon is full because some weird timing thing happened. It's really beautiful. Okay. And the last concept is called a lifetime. And this is how we decide when to release memory. Every allocation gets a lifetime. In this case, our vec is created within the function main. So its lifetime starts where it is, and it ends at that second the right-hand curly brace. And so when something goes out of scope, the compiler put code there when it was compiled to release that memory. And of course, if that vec contains other things that are also on the heap, it follows the whole train down. But again, this all happened at compile time. So you have a very good idea of when your memory is going to get allocated and deallocated, and not some random GC pause that you weren't expecting. But the beauty part is, for the most part, you don't have to worry about it. It just happens. And you end up with a program that runs faster, tends to start instantly. I love the Java lag when you try and run something. And you're going to tend to use less memory in general because you're not also loading a JVM next to your program. Okay. I'm not meaning to pick on Java, really. Okay, enough about memory. Let's talk about some other cool things about Rust. It has closures. I remember when I first started writing Ruby, I was like, I'm never going to use a language ever again that doesn't have closures. So this was a requirement for me. It also has a really cool type system. I know type systems don't excite everybody, but I'm not one of those people. It includes a neat thing called an algebraic type, which I won't go into all the details, but it means something can be one thing or another, which really helps in error handling. It has a full support for traits. If you're used to Java interfaces or something like that, traits are fairly similar, but they have their own thing. And something really cool called pattern matching, which helps you undo those algebraic types. If you've used Haskell or OCaml, these things should sound sort of familiar. But probably the most important thing about Rust I found is the community. It's really great. People are very supportive. You can jump in their Discord and just ask the stupidest question in the world, and you'll probably get some help. So I find that to be a definite bonus. But of course, there are some downsides. There have to be. With a more complex compiler come longer compile times. But they've done a lot of work in the last 2-3 years especially to lower those compile times. They've got the incremental compiler working really well now. So that first compile will still take a bit. But after that, all your other compiles will be really, really quick. I like to quote myself, by the way. All right. It also has a bit of a learning curve. Because memory management is different than you've ever seen on any language, and maybe unless you've used OCaml, it will take a bit to get used to Rust. You'll fight. It's called fighting the borrow checker. When you first get in, you're always going to be like, "What do you mean I have this reference and you can't do?" You know. But once you get used to it, it's really great. All right. So I've convinced you, right? You're going to run out and learn Rust today. Tonight. So here are some resources. They have a book. It's free. It's online. You can also buy a Dead Tree version if you want to. There was a podcast called the New Rust Station podcast. They're not doing new episodes anymore, but they have a really great back catalog. And he teaches all kinds of great things like lifetimes and borrow checkers and all kinds of weird things about the trait system that you need to learn at some point. The Rust team themselves did a bunch of really introductory screencasts at intorust.com. That's a weird inside Rust joke, but you'll get it later. If you're into the exorcism.io site that teaches you how to jump from language to language and learn lots of stuff, they have a whole directory full of Rust exercises. They have the forums, and also if you don't even want to take the jump in running that curl command and piping it to bash, you can go to their playground and actually compile and run Rust right in your browser. I should have put on the downside list, there is no REPL for a language like this, right? Because it's not a dynamic language running in an interpreter. This is the closest you're probably going to get, and it's quick, it's fast. Plus, they actually include a lot of third-party libraries from crates.io, so even if you want to try out a library real quick without even putting it on your machine, you can get over there. So, the next time you're thinking about programming languages, maybe you'll give Rust a try. Thanks.
You guys are done clapping already. I'm not even on the stage. Thank you so much, Tony. So, yeah, like, oh, yeah, absolutely. Like, right here I did. Right in my feels, where I was like, oh, sorry, you're so stupid. You guys, I'm smart in other ways, okay? I'm smart in other ways. That's not one of them. Swift, Taylor, I know about her. I don't know about any of these things. I really like this swirly thing. It reminds me of cinnamon twists, and I really would like that in my life, if I'm being honest. Please, somebody bring me. Oh my gosh, I just laugh when y'all are laughing to like add to what's happening in the room. Okay, y'all, we're all done except just a couple of things because I have the microphone and you do not. I would really like to know, y'all know some developers, right? This is a really